6th standard students, let us start from page number 142, equivalent fractions. Look at all the representations of fractions. You can see here two parts are there and from one part is shaded. Then another box, 4 parts are there, 4 equal parts are there and 2 parts are shaded. Then 6 parts are there and 3 parts are shaded. These fractions are 1 by 2, 2 by 4, 3 by 6, representing 2 parts taken from the total number of parts. If we place the pictorial representation of one over the other, they are found to be equal. You can see all the 3 are equal. Only what we have done here, divided from this way and from here last in this way. Clear? Now try this. Are 1 by 3 and 2 by 7, 2 by 5 and 2 by 7, 2 by 9 and 6 by 27 equivalent? Give reason. So see here 3. That means box is divided into 3 equal parts and out of 1 is shaded. Now same size box you will make and then equal parts and 2 parts you will shade. Now 2 by 5, 2 by 7, 2 by 9, 6 by 27. Equivalent. So you will do same activity, you will same box you will and out of in this way only one part you will shade. Now give example of 4 equivalent fractions. In this way also you can give. Box you will take, so 2 boxes first you will shade and in place of this you can 6 boxes, 8 boxes you can take, and in this way you can make equivalent fractions. They are equal or not. Identify the fractions in each. Are these fractions equivalent? So see here, total 8 parts, out of 8, 6 by 8. Then from here 1, 2, 3, 4, total 12 parts, out of 9. And cover all these parts one another. If it is equal, then. But simple way I am telling you, you will see in the next, on the next page. 1, 2, 3, 4, 4, 4 1s are 4 2s are 8, 4 3s are 12, 16 parts are there and out of 16, 3, 6, 9 and 12 parts are there. 1, 2, 3, 4, 5. And here, so 1, 2, 3, 4, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 20 out of 20, 5, 10, 15 parts are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Clear? Now see. First is, if we will divide this and this number by 2. So 3 by 4, divide by 3. 3 3s are 9, 3 4s are, divide by 4. 4 3s are, 4 4s are, divide by 5. 5 3s are, 5 4s are. So everywhere you will get 3 by 4, 3 by 4. And if you will cover one another, so these are equal. So equivalent fractions. These all are equivalent fractions. Now, understanding equivalent fractions. 1 by 2, 2 by 4, 3 by 6, 36 by 72. 1 2s are 2, 2 2s are 4, 1 3s are 3, 2 3s are 6. Are all equivalent fractions? They represent the same part of the whole thing. Discuss and write. Why do the equivalent fractions represent the same part of whole? How can we obtain one from the other? See here, 1 2s are 2, 2 2s are 4, then 1 3s are 3, 2 3s are 6, 1 4s are 4, 2 4s are 8. Same number. So, same number we are multiplying in the numerator and denominator. So to find an equivalent fractions of given fraction, you may multiply both the numerator and the denominator of the given fraction by the same number. Rajani says that equivalent fractions of 1 by 3. Multiply 1 by 3 by same number, that means 2 in the numerator, 2 in the denominator, so 2 by 6. Again multiply by the same number in numerator and denominator, 3, 3. So do you agree with her? Explain. Yes, we can get, because when we will remove from 2, 2, again original fraction we are getting, that means these all are equivalent fraction of this. Find 5 equivalent fractions of each of the following. Same way we can calculate here. Now another way. Another way is there any other way to obtain equivalent fractions? Look at. Now see here. How many triangles? 6, and from 6 4 are shaded, and here 2 by 3. Now see here, whole part is there, and here 1 2 3. Out of 3 column, 2 parts are shaded. So what we can do, if we will divide by this 2 2s are 4, 2 3s are 6 in this number, so again we can get 2 by 3. So in both the way we can write here. So to find an equivalent fraction, we may divide both the numerator and the denominator by the same number. That means if we are multiplying equivalent fractions, in 2 ways we can find same number, we can multiply in numerator and denominator, and same number we can divide in numerator and denominator, so we can get equivalent fractions. Now one equivalent fractions of 12 upon 15, divide this 12 upon 15 by 3, so 3 4s are 12, 3 5s are 15. So 12 upon equivalent fraction of 12 upon 15 is 4 by 5 also. Can you find an equivalent fractions of 9 upon 15 having denominator 5? Yes, 3 5s are 15, denominator should be 5. So when we will divide this number by 3 and 3, we can get 3 3s are 9, 3 5s are 15. Clear? Illustration you will solve. Now an interesting fact. Another way. Let us now note an interesting fact about equivalent fractions. For this, complete the given table. The first 2 rows have already been completed for you. Okay, equivalent fractions 1 upon 3, 3 by 9. Now cross multiply, that means product of the numerator of the first and the denominator of second. Numerator of the first and denominator of the second, that means 1 into 9, 9, 3 3s are 9. Are the products equal? Yes. Now 4 into 35, 5 into 28. Yes. 16 ones are 16. You will fill 4 into 4, 16. Yes. 15 twos are 30. 10 threes are 30. Yes. 3 into 56. 7 into 24. If both product of both or both the values are equal, then equivalent fractions are there. So what do we infer? It is the meaning that when we multiply, cross multiply when we take, so both the products are equal. The product of the numerator of the first and the denominator of the second is equal to the product of denominator of the first and the numerator of the second in all these cases. These two products are called cross products. Work out the cross products for other pair of equivalent fractions. I will teach you when we can apply this method. Do you find any pair of fractions for which cross products are not equal? This rule is helpful in finding equivalent fractions. When we are finding given fractions are equivalent or not, then we can check by this method. Now see here, simplest form of a fraction. In simplest form of the fraction, what we will do? Given the fraction this, let us try to get an equivalent fraction in which the numerator and the denominator have no common factor except 1. That means no common factor should be there between 36 and 54. Then we will call simplest form of this fraction. So see here, when we will divide by 2, so we can divide more time here when we are dividing by 2, and these two numbers also divisible by 3. Clear? After dividing by 2. So when we will divide by 3, we will get 6 upon 9. And 6 upon 9 also we can divide by 3. So 3 2s are 6, 3 3s are 9. So one by one, if you will divide, you will get at the end 2 and 3. So you can see here, between 2 and 3 except 1, there is no common factor. So we can say that it is the simplest form of 36 upon 54. A fraction is said to be in the simplest form or lowest form if its numerator and denominator have no common factor except 1. Now the shortest way we will learn. The shortest way to find the equivalent fraction in the simplest form is to find the HCF of the numerator and denominator and then divide both of them by the HCF. This method I will teach you on the green board. Now again, the equivalent fractions given here are quite interesting. Each one of them uses all the digits from 1 to 9 ones. See here, 2 upon 6, 3 upon 9. 58 upon 17. Try to find 2 more such equivalent fractions. So in this you can see here all the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. All the digits are used. So you will try to find 2 more such equivalent fractions. Clear? Now try this. See on the next page, illustrations you will solve. Write the simplest form of this 5 questions, and is this in its simplest form? So we will check. From here 1 or 2 I will solve, and this I will explain. Now see here, given fraction 15 upon 75. So prime factorization, we will take 15 and 75. 3 5s are 15, 5 1s are 5. Then 3 2s are 6, 3 5s are 15, 5 5s are 25, 5 1s are 5. Now 15. In place of 15 we can write 3 into 5. In place of 75 we can write 3 into 5 into 5. Actually 3 cancel by 3, 5 cancel by 5. We can take from here HCF also. First we will write prime factorization, then common factors, then highest common factors we will take. So in this way also it is the easiest form. Method is same. So we can take in this way. So in the numerator you can see 1 is left, and in the denominator 5. So 1 upon 5 will be the answer. Now next question is 16 upon 72. So first prime factorization you can see 2 8s are 16, 2 4s are, then 2 2s are and 2 1s are. Then 72 divided by 2 36 times. Then 2 18, 2 9s are, 3 3s are, 3 1s are. Then in place of 16, 2 into 2 into 2 into 2. And in the denominator 2 into 2 into 2 into 3 into 3. 2 cancel by 2, 2, 2, 2. In the numerator 2 is left, and in the denominator 3 3s are 9. So the simplest form is 2 upon 9. See here, one of the factor should be prime. So prime number is 2. Now we will check 49 and 64 is in its simplest form. So see here, 49 is directly divisible by 7. 7 7s are 49, and this 64 divided by 2 32. Then 32 divided by 2 16 times. 16 is divided by 2 8. 8 is divided by 2 4. 4 is divided by 2 2. 2 1s are 2. So you can see here in the numerator and denominator there is no common factor. So again we will write 7 7s are 49 and 64. So we can write yes, 49 upon 64 is in its simplest form. Clear? Let us start exercise 7.3. Write the fraction. Are all these fractions equivalent? See here, 1 by 2, 2 by 4, 3 by 1, 2, 3, 4, 5, 6, 3 by 6. Then next is 1, 2, 3, 4, 5, 6, 7, 8. So 4 by 8. Clear? And yes, all are these in equivalent fraction. You can see here, divide by this. This circle, if we will cover on it, they all are equal. Now see here, 4 upon 12, 1 upon 3, then 3 upon 9, 1 upon 3, because 3 ones are 3, 3 threes are 9. Now 2 upon 6, so 2 ones are 2, 2 threes are 6, 1 upon 3, 1 upon 3, then here 1, 2, 3, 4, 5, 10, 15. So in the denominator 15 and in the numerator 1, 2, 3, 4, 5, 6. So 6 upon 15 divided by 3. 3 2s are 6, 3 5s are 15. When we will write 6 upon 15. So here 1 upon 3, 1 upon 3, 1 upon 3, 1 upon 3, but here is 6 upon 15, that means 2 upon 5. So it is not equal. It is not equivalent fraction. See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 6 upon 15 only divided by 2. And here we are getting 1 by 3. Now question number 2. Write the fractions and pair up the equivalent fractions from each row. So for this, what you will do? Here first we write the equivalent 1 upon 2a. Then second is 4 upon 6. Then 3 upon 3, 6, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 3 are shaded. Then here 1, 2, 3, 4, 5, 6, 7, 8. Out of 2 are shaded. From here 3 by 4. Okay. Now see here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Out of 18, how many are shaded? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 2s are 18 because divided by half. That means in triangular shape. And out of how many triangles are shaded? 1, 2, 3, 4, 5, 6. 6. Now here 1, 2, 3, 4, 5, 6, 7, 8. And here 1, 2, 3, 4. 4 2s are 8, 4 3s are 12, 4 4s are 16. Out of 16, how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So out of 12, how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Out of 16, 1, 2, 3, 4. So now we will take reduced form of half. And here 2 2s are 4, 2 3s are 6. That means 2 by 3. Here 1 by 3. Here 1 by 4. 2 1s are 2, 2 4s are 8. Here 3 by 4. Okay. Here 6 1s are 6. 6 3s are 18. So C and 1, the pair of equivalent fractions. Then 4 1s are 1, 4 2s are 8. Here A and second is in the same equivalent fraction. Then 4 3s are 12, 4 4s are 16. 3 by 4. So 3 by 4, that means E and third both are equivalent. Then 4 2s are 4, 3s are 2 by 3, that means B fourth. 4 1s are 4 4s are 1 by 4. So fifth is D. Clear? Now replace in box each of the following by the correct number. So correct number. See here, 2 4s are 8. So 4. Okay, in the numerator we are multiplying by 4, so in the denominator also. So 7 4s are 28. So here you will fill 28. Now 5 2s are 10. So 8 2s are 16. 3. So see here 5 4s are 4 we are multiplying in denominator. So here also 3 4s are 12. Now 15 1s are 15. 15 2s are 30. 15 3s are 45. So this 3 we are getting 3. So if we multiply here by 3, then we will get result 45. So that 3 we will divide here. 3 2s are 6. So 20 will be the answer. If we will write 20 here, so 15 3s are 45, 20 3s are 60. So if reduced form is given, then what we will do? We will vice versa. What we will do? 15 1s are 15, 15 2s are 30, 15 3s are 45. That 3 we will divide here. So whatever quotient we are getting, we will write here. So 15 1s are 15, 15 2s are 30, 3s are 45, 20 3s are 60. Now see here, same. 4 6s are. That 6 we will divide in the numerator. So we will get 3. So now check. So 4 6s are 24. 3 6s are 18. Now find the equivalent fraction of 3 upon 5 having denominator 20, numerator 9, denominator 30, numerator 27. So from here you will start in CW your work. In question number 4 you will write question number 1. In place of 4 you will write in your CW notebook 1 question, and this 3 question you will do only in the textbook. Clear? So let us start. Now given fraction is 3 upon 5 whose denominator is 20 and both are equivalent fraction. So numerator we don't know, suppose that we are assuming x. So given fraction is 3 upon 5, then 3 upon 5 is equal to x upon 20. We know both are equivalent because we will take reduced form, they both will be equal. Now whatever value we have to calculate, we will take this side. So x upon 20, RHS will become LHS, LHS will become RHS. So we will change the side. X upon 20 is equal to 3 upon 5. Now we have seen that in that table, cross multiplication always be equal in the equivalent fraction. So cross multiplication 5x 20 into 3. So x equal to 20 into 3. 5 is in the multiplication. So it will be in the denominator. So 5 1s are 5, 5 4s are 12, 4 3s are 12. So numerator will be 12. Clear? So we will get the numerator 12. Now fraction. So the fraction is numerator is 12 and denominator we know already given in the question 20. So equivalent fraction of 3 upon 5 whose denominator is 20. So the fraction is 12 upon 20. See here 4 3s are 12, 4 5s are 20. So again we are getting same fraction. Clear? Now we will calculate equivalent fraction of 3 upon 5 whose numerator is 9. So first we will calculate denominator because denominator we don't know. So 3 upon 5 equal to numerator is given 9 and denominator we don't know. So we will write x. Now cross multiplication because equivalent fractions are given. So cross multiplication always be equal. So 3x into 5 into 9. So x equal to 5 into 9 is there. Now 3. So we will take in the divisions with division sign, that means in the denominator. 3 1s are 3, 3 3s are 9. So 5 into 3 is left and we can neglect this 1 because it is in the denominator. So 5 3s are 15. So what is the denominator? 15. So equivalent fraction of 3 upon 5 whose numerator is 9 and denominator is 15. So fraction is 9 upon 15. So the denominator is 15 and equivalent fraction is 9 upon 15. Clear? Rest of the two you will solve. Now fifth is find the equivalent fraction of 36 upon 48 with numerator 9. So 1 I am solving for you and denominator 4 you will solve. Okay. So I am solving for A. Now see here, given fraction is 36 upon 48 and its equivalent fraction we have to calculate whose numerator is 9 given. So denominator we are assuming x. Now we know cross multiplication always be equal when the equivalent, both are equivalent fractions. So 36 into x equal to 48 into 9. We have to calculate the value of x. So x equal to 48 into 9 as it is, 36 will be in the denominator. So see here, 9 ones are 9, 9 fours are 36, so 4 ones are 4, then 4 ones are 4, 4 twos are 8. So x equal to 12. What is x? X is denominator. So the denominator is 12 and equivalent fraction of 36 upon 48 is 9 upon 12. And B, you will solve. Now sixth, check whether the given fractions are equivalent or not. So by cross product we will check. Okay, so I am solving for you this one, rest of the you will solve. Now see here, given fractions are 5 upon 9 and 30 upon 54. We know if the fractions are equivalent, then cross product should be equal. So 5 into 4. So 5 into 4 is, here is in the denominator. So 5 into 4, 270, 5 4s are 20, carry over 2, 5 5s are 25, 25 into 27. So 9 zeros are 0, 9 3s are 27. See here. So here 5 into 54 equal to 9 into 30 equal to 270. So we can say that both the values are equal. So we can say that 5 upon 9 and 30 upon 54 both are equivalent fractions. In this way you will check. Now seventh question, deduce the following fractions to simplest form: 48 upon 60, 150 upon 60, 84 upon 98, 12 upon 52, 7 upon 28. So I am solving for you this two, first two, and you will solve this three. Clear? Now see here, given fraction is 48 upon 60. So prime factorization of 48 and 60. So 48 divided by 2, 24, 24 divided by 2, 12 times, 12 is divided by 2, 6 times, 6 is divided by 2, 3 times, 3 ones are 3. Now 60 divided by 2, 30. Then 30 divided by 2, 15 times, 15 is divided by 3, 5 times, 5 ones are 5. You can see here. So in place of 48 we will write 2 into 2 into 2 into 2 into 3. In place of 60 we will write 2 into 2 into 3 into 4. So you can see here, numerator and denominator, 2 cancel by 2, 2 cancel by 2, this 3 cancel by that 3. So left value is 2 into 2 upon 5. So 4 upon 5. So one number should be prime. So you can see there is no common factor except 1 in these two numbers. So simplest form of 48 upon 60 is 4 upon 5. Given fraction is 50 upon 60. Now we can write 50. 10s are 6. 10s are 10 cancel by 10. And we can directly cancel 0 by 0 also. In rough work you can see 0 cancel by 0. So 15 upon 6 is left. Now prime factorization of 15. 3 5s are 15. 5 1s are 5. 6. 2 3s are 6. 3 1s are 3. Now 15 upon 6 in place of, we can write 3 into 5. 2 into 3. 3 numerator. You can see 3 in the denominator. So 3 cancel by 3. So left value is 5 upon 2. So 5 upon 2 is the simplest form of 150 upon 60. Now 8th question. Ramesh had 20 pencils. Sheelu had 50 pencils and Jamal had 80 pencils. After 4 months, Ramesh used up 10 pencils. Sheelu used up 25 pencils and Jamal used up 40 pencils. What fraction did each use up? Check if each has used up an equal fraction of her or his pencils. So let's solve on the green board. Given Ramesh, Sheelu and Jamal had 20, 50 and 80 pencils respectively. After 4 months, Ramesh, Sheelu and Jamal used up 10, 25 and 40 pencils respectively. It's given. Now fraction form. Fraction form, out of 20, 10 pencils used by Ramesh. So fraction form, 0 cancel by 0, so 1 upon 2. By Sheelu, 25 upon 50. So 5 into 5, 2 into 5 into 5. This 5 cancel by this 5. So 1 upon 2. By Jamal, 40 upon 80. Cancel. 0 cancel by 0. 4 ones are 4, 4 twos are 8, or 2 into 2, 2 into 2 into 2. So 1 by 2. So you can see all are equal fractions. So equal fractions they have used. Now match the equivalent fractions and write 2 more for each. So first match and you will write two more fractions of it. So 0 cancel by 0, 5 5s are 5 8s are, so 5 upon 8 D. And you have to write more two fractions. So 5 2s are 10, 8 2s are 16, 5 3s are 15, 8 3s are 24. Clear? So you will write here only match the following. In this way you will do. Okay? This question you will change the statement and write match the following. Now 0 cancel by 0. Then divide by 2. 2 9s are 2 10s are. 9 upon 10 E. So 9 2s are 18, 10 2s are 20, 9 3s are 27, 10 3s are 30, 27 upon 30, and 9 2s are 18, 18 upon 20 will be next two more equivalent fractions. Now 0 cancel by 0, 11 3s are 33, 11 6s are 36, 11 9s are, then 3 2s are 3 3s are, 2 upon 3 here, 2 2s are 4, 3 2s are 6, so 4 upon 6, and you can take more. Now 0 cancel by 0, 18 1s are 18, 18 2s are 1 upon 2, then 0 cancel by 0, 11 2s are 22, 11 5s are 55, so 2 upon 5 is the next fraction. So here the 7.3 is finished.